Have you ever wondered what it's really like to live in space? We're dedicated to the exploration of outer space and humanity's mission to explore the universe. Get the latest news and updates from SpaceX, NASA, Starlink, Blue Origin, and the James Webb Space Telescope. Let's dive into the astonishing reality behind the scenes. The reality of the International Space Station? Welcome to Fact Epics. The 1980s, a new player enters the space race. In the early 1980s, the space race saw a significant shift. The previous decade had seen the Soviet Union experimenting with small, primitive orbital space stations, while the USA had launched one large, advanced station. Neither approach succeeded in establishing a long-term outpost in space. Enter Europe, a new major player. The European Space Agency had demonstrated expertise in constructing and operating research satellites and had developed its capable orbital rocket, the Ariane 1, which first launched in 1979. During this era, NASA had just completed its investment in the Space Shuttle project, which first flew in 1981. The Europeans responded with Spacelab, a reusable laboratory developed by ESA to fit inside the shuttle's cargo bay. In many ways, this was the first international space station. Spacelab added significant value to the shuttle program, enabling astronauts to conduct experiments in orbit. The European hardware was versatile, allowing various configurations within the shuttle bay to meet different mission objectives. The pressurized Spacelab module flew on 16 shuttle missions starting in 1983 and continued until 1998 when orbital research transferred to the ISS. This collaboration marked a new era of international cooperation in space exploration. A new vision for space, challenges and collaboration. In January 1984, President Ronald Reagan set forth an ambitious vision for space exploration during his State of the Union address. Tasking NASA with developing a permanently manned space station in cooperation with allies, Reagan aimed for scientific research and industrial advancements, targeting a launch by 1992, coinciding with Christopher Columbus's 500th anniversary. The initial design concept, the Power Tower, featured a vertical truss with modules at the base and solar panels above. Simultaneously, ESA pursued its space station project, led by Germany, Italy, and France. France developed the Ariane 5 rocket to support Europe's manned spaceplane, Hermes, while Germany and Italy focused on an orbital research laboratory named Columbus. However, 1986 brought setbacks. The Challenger disaster in January halted American progress, while the Soviet Union celebrated success with the launch of Mir, the first modular space station. Despite the tragedy, international support for the space station project grew, with contributions from Europe, Canada, and Japan. By 1987, plans evolved into a horizontal truss design with modules and solar arrays. The revised launch date of 1994 saw contributions from various nations, promising a collaborative future in space exploration. In 1988, President Reagan named the project Freedom. The Western superpowers now had their counterpart to the Soviet Mir, symbolically highlighting the ideological divide. However, the Freedom Station came with a hefty price tag of around $15 billion in the 1980s money, sparking significant opposition from the U.S. Congress. The cost and timeline of the Freedom Station led to intense conflicts between NASA and the government. After 3 years of disputes, budget cuts, timeline changes, and multiple redesigns, the Freedom Station project had morphed into a less practical design. One iteration even proposed using a refitted space shuttle orbiter as the core module, with wings, landing gear, and heat shield removed to maximize payload capacity. This would allow a 56-foot-long pressurized module to be mounted, but it illustrated the extent of the compromises and challenges faced. A controversial redesign and the Soviet Union's collapse. The ISS design underwent significant changes, including a controversial proposal to use a refitted space shuttle orbiter as the core module, with 4 pairs of 120-foot-long solar panel arrays that would roll out in space. Despite universal disdain for this design, a new opportunity for space exploration emerged in December 1991 when the Soviet Union dissolved, transforming into a collection of independent nations. Russia's emergence and space station Mir. Russia, now free from Soviet rule, had a well-developed space station, Mir, which had expanded to a 4-module configuration, featuring a dedicated astrophysics lab, X-ray telescope, ultraviolet telescope, and biotechnology experiment lab. This newfound independence and space capability caught the attention of the US government and NASA, leading them to extend an olive branch of friendship to Russia. This cooperation wasn't unprecedented. The 1975 Apollo-Soyuz mission marked the end of the original space race, with NASA's Apollo spacecraft docking with a Soyuz capsule. Economic hardships and strategic decisions. The collapse of the Soviet Union led to a severe economic downturn in Russia, with GDP falling by roughly 50% between 1990 and 1995, a decline even steeper than the US Great Depression. The Russian space program suffered immensely, with rocket scientists and engineers facing little to no funding. This dire situation prompted the US government to invite Russia to become a full partner in the space station program in 1993. This program, renamed from Freedom to International Space Station Alpha, would ensure job security and funding for Russian space experts, mitigating the risk of their defection to hostile nations. The Alpha was dropped from the name in 1995, and the partnership brought hundreds of millions of dollars into the Russian space program. Despite the collaboration, the quality and reliability of Russian hardware were not considered high. One of the Russian modules was a recycled Soviet leftover from the mid-80s, which faced delays and budget overruns. The US ended up spending over $1 billion to fund Russian manufacturing, leading some to view the ISS as a disguised welfare program to prop up the failing Russian space economy. The Shuttle Mir program. The Shuttle Mir program, beginning in 1995, marked the first step in this partnership. A new module for living quarters and NASA-sponsored experiments was added to Mir, followed by a docking module delivered by Space Shuttle Atlantis. This collaboration allowed Americans to learn from Russian expertise in long-duration spaceflight, extending Mir's lifespan from 5 to 15 years. The construction of the ISS. Orbital construction of the ISS began in 1998, 6 years behind Reagan's goal and 4 years behind the revised Freedom date. The first module, Russia's Zarya, provided power and propulsion. It was joined by NASA's Unity module, forming a link between the Russian and American sides and serving as the main dining area for the crew. The third module, Zvezda, originally built in 1985 for the Mir program, provided life support and housing for the Russian crew. With these modules in place, the ISS became habitable. The first resident crew, Expedition 1, arrived in November 2000, launched from a Russian spaceport. This crew included 2 Russians and 1 American, symbolizing the cooperation between the 2 nations. Despite subsequent geopolitical tensions, the ISS stands as a testament to what can be achieved through international collaboration. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more space exploration content.